Hello everybody, welcome back to a training of the Modicon M221. In this video we're gonna see how we can configure the PLC to communicate with one of the power meters that we have in the offer, which is something like this, using the I/O scanner of the PLC over Modbus serial. So let's go to the presentation. Like every Modbus communication, we have a master and a slave. So in our case, the master will be the PLC and the slave will be the power meter, something like this. So there are a few parameters that we need to match in order to establish the communication. So if we go deeper here, you can see that I have the master of the PLC with this information, the baud rate, the parity, the stop bit, the data length, and on the other side, I have the power meter, okay? That in this case, I have the PM5000 series, okay? And I'm going to configure the address 9, the baud rate, and the parity event. These are by default 1 and 8. And in the second part of this model, what we're going to do is to see how we can read this type of information, because it's not enough to know how you can communicate with the device. It's good to know how you can handle the data that you read from the other device. So let's continue. So everything starts with the hardware connection. So in our PLC, we have the RJ45 connector, okay? And on the power meter, what we have is this connector over here. We have 4 cables, okay? So the first 2 are for the Modbus part, okay? The 1, the 0, independent. The each PLC probably it shows us A plus or A minus, so it would depend. But what you need to know is that basically you will need to use 3 cables, okay? Plus, minus, and then the common, okay? And if you take a look on the PLC side, on the RJ45, we can see this, that we have the 4 pin is the 1, this one, the 0, which is the 5, is this one, and then we have the common. Okay, so we can use one of these cables, okay, and probably not the best, but you can cut one of the part, okay, and use the pin 4, 5, and 8, an additional the shield, okay. So in this way you can establish the Modbus communication. So once you establish this part, the hardware, that the hardware is correct, what you need to do is to configure the power meter. So you can follow this, that basically you will need to go into the maintenance, go to the setup, enter into the setup for the communication. By default, the password is 0, and then you can modify this parameter. So let's try to do that on our side. So I have this power meter, so I'm going to the maintenance, okay, maintenance, setup, the password 0, okay, communication, and here I have the possibility to change the address. If I go down, then I have the option to edit, and in order to change this you just need to press the plus, and if you want to change the others you just need to press this one. So imagine that the number is 20, just go here. If you go this one to go here, you just need to plus until it reaches the value that you want. Okay, in our case, what we're going to do is to select the slave address 9. So this one should be 9, this one 0. Okay, we also need to check the others configurations. The baud rate is correct, is the one that we want, and the parity is all right. So we can go back, and we must save the changes. Okay, okay, good. Now we can go back, and that's it for the power meter side. Okay, so for the power meter, just need to configure those parameters, and that's all at the moment. There is nothing else to do. So now what we're going to do is to see how we need to configure the PLC side. So let's go to the presentation. So once we have configured the device, it's time to configure the PLC. And here we have different possibilities. We can use the Modbus function blocks, as I explained in the previous part of the module, that you can use the read and write bar, but probably that can take more time. That's why I want to show you how you can use the Modbus serial IO scanner in order to easily read and write information. So let's continue. In order to configure the serial line is easy. We just need to go to configuration, select the serial line port that we're going to use, and select the protocol, the Modbus serial IO scanner. Then change the view. What we need to check is that the serial line configuration matches the one that we have on the other side. Okay, you can see here the parity is correct and the baud rate is correct. This one is by default on the other side. It's like this. So once we have configured this part, it's time to start using the device, make the configuration. So once you selected the serial line IO scanner, we just need to select the transmission RTU, which is by default. Then in our case, we just need to go to others and select the generic one. Once you add the generic, we need to optional, we can change the name, and we need to change the slate address, that in our case is the 9 that we have already configured. Then we have this initial request that if you want to send some initial configuration for the device, you can specify some channels in the initial request, so the PLC can send to the device, in our case the power meter, the initial configuration for some parameters. That is the idea. In our case, we are not going to do that. We just going to delete what is inside the initial request. So we just need to enter over there, select, right click, and delete. What is important now is the channels. With the channels are like the pre-configuration of the variables that you want to read from the slate device, so you can use it in our software. Okay, that's basically the idea. So once we enter in the channels, what we need to do is to configure what we're going to read. And by default, we have one channel over here. And when we go into the configuration, we can see this list. So first, we need to define the type of message that we are going to use to communicate with the device, or in which area of the slave the information is located. So for example, if you want to read a percentage NWU, you probably need to use this one, multiple words, or write multiple words. Okay, it would depend on the variable that you want to read. Okay, then you need to specify the trigger, that the trigger can be cycle. Okay, so every time that you have configured, the PLC is going to read and write information, or you can configure a variable, okay, to trigger the channel to start the communication, read and write. Once you have configured that, what you need to define is where the information is located on the slave. So if you want to read, you need to specify the offset. And if you want to write, you need to specify the offset and the amount of information that you want to read. So this is similar to the function block that we use for read and write, but here you can have a better visual of how you can configure the channel to communicate and share information with. So if you take a look, it's very simple. You just define the message type, which is basically where the variable is located on the other side in the slave. Then once you know that, you just need to define which function. Then you need to define in that area of the slave where that variable is located, and then you can specify, okay, from that position I want to read too many variables. That's basically the idea, read or write. That is the idea of using this. So just to let you know, if you take a look in the Modbus function, okay, this is the one that we have on the PLC, and this one are the standard for the Modbus. So if you take a look here, for example, read multiple words, it seems to be the same, but it's not. So if we go here, the function 03, okay, function code 03, it's for read holding registers, okay, and this one 04, 04 is for input registers. So there are differences over here, and that is something that we need to take a look on the communication table on the other device. And in this case, it will be the power meter. So it is important to download the communication table, the Modbus register that we have for the SLA device, in this case, this one, in order to know what what to need what we need to read or write. Otherwise, it's going to be useless. So let's continue with this. So now it's time to read some information from the other device. So what we're going to do is to configure the IO scanner. And in the IO scanner, what we're going to do is to read the product ID number. Okay. So in this particular case, as I mentioned in the other videos when I communicated with the M172, we need to check if it's base 0 or base 1. And depending on that, we need to subtract or not one unit to the register that we want. In this case, we need to subtract 1. So if you take a look here, I want to read from the power meter the register number 90, but on the PLC I need to specify that the offset is the 89 to read the proper value that I want. So if we go to the software of the PLC, I have this. So I already configured the IP address, so I can download the application over there. Then on the serial line, I need to configure Modbus Serial IO Scanner. This is the same configuration I want, so I need to apply. Then on the Modbus Serial IO Scanner, what we need to do is to add a generic device. Add. Here we can modify the name. Let me just double check what is the name that I have assigned here before. So I assign power meter 5XX Modbus. Okay. Here I need to specify the slave address, which should be 9. Okay, and the initial request, here I don't need any initial request, so I'm going to delete it. Okay. And now it's important to predefine or configure the channel. So here there is one channel, so we can name this channel to easily identify later. So I'm going to name this, we can do it over here in the configuration. So I'm going to name this as PM5XX Modbus register 0090. Here I'm going to specify to read multiple words, okay, because it's a percentage NW. And if you take a look into this is the table for the power meters. So if go back here, you can see the registers, okay, and you can see the size and the data type. And if you have any doubt for the data types, you can go to the specific part of the sheet in order to check what is inside that data type. But what is important now, I'm going to read this, the product ID number. So I need to point to that register, but I mentioned before, I need to subtract 1, okay, and we should be able to see this information. So 89, and I want to read only one word, okay, because the size of this product number is 1, okay. Once this is configured, we just need to okay. We can also change the name. This is the product ID number. Just product ID number. Okay, and okay again. So we have in this part what we have done is to configure the PLC, the Modbus part, and define which information I want to read from the other side. Okay, we haven't downloaded anything yet, so let's continue with this. So let's go to the presentation. Now, once we have defined the channel, okay, inside the programming part, network objects, we can find this input register, okay, for the IO scanner. And depending on the type of variable, the channel information will be there. Okay, so in our case, just go back to the program. In our case, we have defined a percentage NW variable, okay, to read multiple words. So if we go to programming, let me just save these changes. Okay, as you can see, there is empty. If we go to tools, network objects, we can see here the IO scanner. I don't have anything on digital inputs, outputs, or outputs because the channel is only for input register. And you can see here I have the channel I have already configured. So in here, okay, in order to use this information in our code, for example, if I want to enable the execution or something, and I want to compare, for example, that the number, let me see, should be this one, okay, because it's the model that I have. If the percentage IW and 100.0.0 is equal to this, then execute this. Sometimes it's a little bit annoying to remember this, so it's much better to know to define a symbol for this. So if we continue over here, I believe I have already specified a symbol for this. No, yes. So what we're going to do is to define a name, a symbol for that variable, okay, and also a comment, and create an animation table to see that variable. So let's go back here, symbol PM5XXX product ID, and here we can specify power meter product ID number. Apply. So what we need to do now is to create an animation table underscore power meter, and here instead of using IW we can use the PM5, the name of the variable that we have already defined. Okay, so now if we connect with the device, okay, log into the controller, download, okay, just wait for this to finish, play, yes, we should be able to read information, okay. As you can see, I'm reading the information from the controller, and if I press this one, you can see that it's activated and the logic works. So what I have done here is to basically read one variable, the product ID, that in this case is is this model, okay? I can show you over here is this one, okay, the one that I'm connected with. So as you can see, it's simple just to read information, but depending on the data type, probably can be a little bit complex. So that part of the data type we're going to see it later, but now it's not enough to know that I'm able to communicate. It's also good to know why I cannot communicate sometimes. Okay, that's why we need to figure out how we can troubleshoot in the communication. So let's continue with the presentation. I'm going to log out from the controller. Okay, good. So let's go to the presentation again. This part is already complete. So in order to know why we don't have communication with the device, okay, we have these tools, okay, and the IO scanner status that allowed us to check if the offset of the device is wrong configured or there is another issue. And we also have these system words, the SW210 and SW211, that allows us to see the status of the serial line. So if we follow this, if everything is good, okay, the status of those variables will be in 2. Otherwise, probably we have a problem. So we're going to add this SW210, in our case, because we're using serial line 1, in our animation table. Let's do that first, so I don't forget. So here, SW210. Okay, here we can see later the status of the serial line. Let's continue with the presentation now. So if we want to know for this part, the IO scanner status, the status of the channel and of the device I have configured, it's important to know what is this information. So when we are in the IO scanner status, we have these variables over here. And in order to identify, okay, you can see in colors, in the orange one, that the orange is related to the device, okay? So you can see in this example, I have already added 2 more devices, okay? And this is the structure. So the IO scanner structure starts with the I, W, and S, and the 100, 200, or 300 depends on the communication. In our case, for serial line 1 is 100. If it's for serial line 2, it should be 200, okay? But in our case, if it's serial line 1, it should be 100, okay? And then the next one will be 101, 102, okay? So this allows me to identify the status of each device. Now, if you have configured a channel inside, then we have more information. So depending on the channel ID that you have over here, okay, it will add additional information. So for this one that is not empty, as you can see over here, I have these 2 channels already configured. This is just an example. So you can see here that I have the 100.0 that is related to the first channel, and 100.1, which is for the second channel ID 1. Okay, as these 2 doesn't have anything in there, there is no additional variable. So if we go to our example, we have already configured this device, only one device and one channel. You can see start everything in 0. So if we go to the tools, system objects, IO scanner status, we only have 2, one for the device and the other one for the channel. Okay. Now, depend on the value of these 2, we can identify what is the problem or if everything is all right. So let's continue. So the first one for the device, to sum up all this, if you have the value 2, everything is all right. Otherwise, you need to worry and figure out what is the problem. For the channels, if the value is 0, everything is all right, and you don't need to worry about anything, okay? Otherwise, pay attention on the value that you have. So what we're going to do now is to assign a symbol to these two for the channel, for the device, and the other one for the channel, okay? So we can see the status of the communication. So let's go to the program. So programming tools, IO scanner, system object, IO scanner. Here I'm going to define this as, let me just double check, what is the name here? PM5XXX, com status. Okay, and this one is com status channel 0, 0. Okay, PM5XX communication status to equal OK. This one is the channel 0, 0, and in our case the 0 means that it's OK. So what I'm going to do now is to ch00. Let's put it much better this way. I'm going to copy this and I'm going to call this information on the table. Status underscore channel. There we go. So with this information that we have over here allowed us to check if we have a problem on the communication. Okay, so let's go to the PLC and see what is the status of all this. So I'm going to connect. Okay, as you can see, the status means 2 is operational, 2 everything is okay, and 0 the channel is okay. Okay, so let's continue with the presentation. Now, this is a good question. Okay, it's possible to reset the IO scanner. If we have a problem or an issue, we can suspend and also reset the IO scanner. And we have these two variables, the percentage S110 for serial line 1 and the S113 for the serial line 1. So let's add these two variables into the example so we can see what's going on. So just forget this one, percentage S110 and S3. Okay, and additional, okay, we have another variables, this one, and this one, okay, that basically check the amount of frames that have been transmitted. Okay, it's just additional. So right now I'm connected with the controller. Okay, so what I'm going to do now is to disconnect, remove the, let me just double check the power meter. Okay, just show you that I'm going to disconnect it. Okay, I'm going to remove the power supply. Okay, as you can see in there, okay, this is the status 3. Okay, there's no communication at all, or it's partially working. Okay, as you can see here, the information I was reading now is 0 because I had configured that in that way. Okay, and you can see the frames is no longer working. So I'm going to power up again. And in this case, what we need to do is to reset the communication. So you have this S110. I'm going to reset the communication, and you can see everything start working again. Okay, so in this video we have seen how we need to configure the physical connection between the PLC and the power meter, how we have configured using the keys, the direction, okay, all the Modbus configuration, and on the PLC side we see how we can make the read and write of some variables, okay, nothing specific, just to read, and how you can troubleshooting if you have a problem during the communication. So in the next video, what we're going to see is how to read a specific data types that we have in the power meter and how to show that information on the HMI or how to read that information properly on the PLC. So thank you very much for watching this video and I see you on the next one.